So in last video we saw the conditions which we can follow to find our magic square of any size n. Precisely n should be odd. Let me help you with an example to use these steps to find a magic square of size for a 3x3 matrix. Now here I have I created a 3x3 matrix. Here x represent the elements which I will write as I will follow the algorithm, and these are the locations of these elements. So for example, the matrix starts with 0, 0, which is the location of this element is 0, 0, 0, because this is the first row, which is 0th row. As we told you, always the first row and first column will be 0, 0. We will follow this convention. Location of this element is 0, 1. Location of this element is 0, 2. Similarly, location of this element is 1, 0, because this is the first row. Location of this element is 1, 1. Location of this element is 1, 2. Location of this element is 2, 0. Location of this element is 2, 1, and location of this element is 2, 2. Now let me go to the condition. The first step was to find the location of 1. We know that 1 is always located at the middle row and last column. So we'll find that. See, in this example, the size of the value of n is 3, because this is 3 cross 3 matrix, and we want to create the magic square of size 3 cross 3. So let's see the first step, which is determining the position of 1. Since n is 3, so the location of 1 is n by 2 comma n minus 1, which is 3 by 2 comma 3 minus 1. 3 by 2 becomes 1, integer division, and 3 minus 1 becomes 2. So position of 1 is 1, 2. So I'll put 1 here. Awesome. Now the next step is to determine the position of 2. So for that, what we have to do, we'll take the last determined location. Last determined location is 1, 2 as p, q. So this becomes p, this becomes q, and we'll find the next position of next element as p minus 1, q plus 1. So position of 2 becomes p minus 1, which is 1 minus 1, and q plus 1, which is 2 plus 1. So it becomes, let me first write it here, it becomes 0, 3. Okay. Now anytime if calculated column position becomes n, since here the column position is becoming n is 3, so make it 0. So I'll make it, if after making it 0, it becomes 0, 0. So I'll put 2 at 0, 0. So at 2 I'll put, at 0, 0 I'll put 2. Okay, great. So now the next element is 3. I have to determine the position of 3. So I will take last calculated position as p, q. This is p, this is q, and again I will follow the same thing. So the position of 3 becomes p minus 1 and q plus 1. P minus 1 is 0 minus 1, and q plus 1 is 0 plus 1. It becomes, what does it become? Let me write it here. It becomes minus 1, comma 1. Again, as I'll say the same thing. Anytime the calculated row position becomes minus 1, here row position is becoming minus 1, make it n minus 1. So n minus 1 means 3 minus 1. 3 minus 1 is 2. This is as it is. So 2, 1. So my position of 3 is 2, 1. Let me see, where is 3, 2, 1? 2, 1 is here. So here I will write 3. Great. Again, position of 4, same algorithm. 2, 1 as pq. 2 minus 1 is 1. 1 plus 1 is 2. So this is simple. 1, 2. So at 1, 2 I'll put, now see, at 1, 2 1 is already present. So what we have to do? If the calculated position already contains a number, then decrement the column by 2 and increment the row by 1. So what I will do, decrement the column position was 2, determined position was 2, so decrement the column position by 2, which becomes 2 minus 2, 0, and increment the row by 1, so 1 plus 1 becomes 2. So at 2 comma 0 I will put 4. 2 comma 0, 4. Great. Position of 5 becomes, this is PQ, 2 minus 1, 0 comma 1, so 1 comma 1. So similar, and put 5 here. Position of 6, 1 minus 1, 1 plus 1, 2, 0 comma 2. So at 0 comma 2, 6. Position of 7 becomes, what is 0 minus 1 and 2 plus 1. Now this is a little bit tricky. See, whenever we see here that 0 minus 1 is becoming minus 1, we'll see this condition, that anytime if calculated row position become minus 1, then we'll make it n minus 1. We have to check here both the condition, that is, if position of row is becoming minus 1 and the column is becoming n, which is 3 here, then you have to follow this condition, that is the fourth one. If anytime row position is becoming minus 1 and is very important here, column becomes n, switches to 0 comma n minus 2. So I will make it to 0 comma n minus 2, 3 minus 2 is 1, so 0 comma 1. So at 0 comma 1 I'll put 7. Okay. Now next is 8. 8 is that, so 0 comma 1 is my PQ, so 0 minus 1 and 1 plus 1, so it becomes minus 1 and 2. So I will use this condition only, that is row is becoming minus 1, so I will make it n minus 1. So n minus 1 is 3 minus 1, which is 2, so it becomes 2 comma 2. So 2 comma 2 I'll put 8. And the last is 9, for which 2 comma 2 is my PQ. So 2 minus 1 becomes 1 and 2 plus 1 becomes 3. So 2 minus 1, I don't have any problem with this. With the row, the column is becoming 3, so I will wrap it up. So it becomes 3 becomes 0. So it becomes 1 comma 0. So at 1 comma 0, I'll put 9. As you see, this was the these were the elements of magic square. You can see here, I got the magic square. You can find the sum of diagonal and row and column. It is exactly 15. 9, 8 plus 1, 6 plus 6 is 15. 9 plus 5 plus 1 is 15. So this is the algorithm we are going to use. It is pretty simple. Giving me you this algorithm, I can definitely say that you can write a program. You can use the steps, and I will encourage you guys to write a program by your own. And you can ask any question on discussion forum. In the next video, I will try to code this, write a program using this algorithm, and we will create a magic square of this size. If you think you can find another pattern and you can write some other algorithm, please post it on discussion forum. It will be very good for us and for other students also. Thank you.